The history of architecture is the story about the conquest of light. Master architect Le Corbusier wrote this in a 1935 article in which described his obsession with glass as a material. Glass encases our building today and keeps evolving. These distinctive profiles of skyscraper have become powerful images and the symbols of our city. How will this evolution change our future buildings? I'm traveling around the world to visit a league of ambitious new engineering wonders and find out the extraordinary building challenges and the intelligence given to those giants.
Well, I'm so excited!
Le Corbusier said there was a hard struggle between opposing functions of a building. The wall, designed to support a house, and the window, to illuminate but tends to destroy the strength of the wall. This struggle eased when steel and reinforced concrete appeared. They can make columns and building cores to support floors, allowing them to spread out like poker cards arranged horizontally. Solid walls are no longer needed. The facade becomes a huge opening. It's filled by glass and frames and becomes a curtain. The tallest curtain on this planet is in this desert.
I remember when I first visited to Dubai, and there has only few high-rise buildings.
Simon is the design director of Burj Khalifa's curtain wall, which gives this giant the facade needed to survive in the desert. The first enemy is the fierce heat. The facade is curved to disperse sunlight with reflective coating designed to transmit only 20% of the visible light and 15% of solar energy. Another killer is wind. Creating a twist in the building's form can reduce the impact of vortex shedding. With every floor offset to the last, wind cannot be organized and form the vortices strong enough to push the building. In other words, the wind is confused by this shape, and this shape is created with glass. The rounded effect is achieved with flat panels of glass.
I think you can use the small pieces of glass to make it in fat and in segment to create the simulation of the curve. But it is an easy way, and also it's cost-effective and cheaper. But this is not the architect design intent.
Nevertheless, Burj Khalifa pointed to the future of the curtain wall, achieving greater aesthetics and functionality through bending. The future is now.
They want a big pieces of glass with a smooth surface. That the Henderson can do in this.
Hong Kong's futuristic landmark was designed by the team of the late Zaha Hadid, the queen of the curve. The team wanted this building pieced together by the true curve without interruption and to blossom into the sky like real Beninia petals, the symbol of Hong Kong. What was required was the double curved glass facade.
曲面的建筑还是很难去攻克的，就是全世界最难的建筑。
This is where the curtain walls of Burj Khalifa was made a decade ago. Today I'm allowed into this independent workshop where the double curve frame is produced under tight security.
我们这个叫冷弯，就在不加热的状况下，常温下把金属变成弯。 单弯其实技术难度也不大，单弯就相当于我们把它这样一个弧度嘛。但是双曲呢，就是另外一个方面又产生了一个弧度，然后再加扭拧就会变成这样的形态。
The specially designed machine carefully twists the aluminum material. The precision determines whether the frame will perfectly match the wavy glass.
金属它是有回弹的，常温状态下变形的时候，它的表面会有褶皱啊、开裂啊，我们要解决这个变形的问题。一个是力的平衡，一个是材料科学。
It's not enough to make smooth curved frames. The tolerances of each part have to be kept within 3 millimeters, and they can only be confirmed by laser scanning. It works a bit like sonar, using laser pulses instead of sound to create a 3D representation of the product called a point cloud.
用它的激光来建模呢，玻璃是透过去的，对，所以就无法建模。然后通过各种激光的这个光波的不同啊，然后它的反射的一些计算，所以我们这套设备是解决了这个问题。
But lasers can do more than checking.
它建了模型以后，我可以把左右上下的模型通过电脑来视频装。
在软件里面你就可以拼了，能不能拼上，马上就知道了。
All products need to pass the water test. But what surprised me is that curtain walls are actually not simply waterproof coatings.
玻璃幕墙的原理是等压原理，就是让你外面的水可以进去，但是在我第一个腔体前面的前腔就能够把水给流走。
That means curtain walls can breathe and absorb the rain. They form a massive vertical network of invisible drainage where gravity is responsible for draining that rainwater away.
It's rare to see Hong Kong from this perspective, standing on the top of an unfinished building. Underneath our feet is Central, and from those short colonial buildings, the city begins to grow upwards. And then some taller buildings appear around, with concrete as structure, and glass can only serving as windows, not walls. Until later, curtain walls and steel rule the skyline here.
Over 2,000 glass panels are ready to be assembled. They interlock like puzzle pieces. If one piece fails to fit, the rest all go wrong.
因为整座大楼呢，它模拟的是一个绽放的紫荆花的一个形态，导致它在造型上呢会有一些是内凹的或者往外凸的一种状态，所以那些位置都是非常难装的，因为它是整个双曲的。
上下两层其实不在一个垂直线上，
没错。
The largest piece is more than 7 meters long and 1 ton heavy. The extreme demands on precision in the factory will pay off at the construction site.
提前用我们的 BIM 的模型去进行一个模拟，对，模拟它安装的轨迹，就是为了让所有的问题都在前端都解决了。到了现场安装的环节呢，就可以有一个生产方面、安装方面有一个大大的一个提速。
Without this drafting technology, without the digital fabrication technology, without the scanning technology, we cannot build.
所以我们不但有哈利法塔做的最高的楼，我们也做了最难的楼，在技术上觉得还是引以为自豪的东西。
Today the race is not about height anymore. It's about curve and difficulties and environmental friendly. From here, we're witnessing an evolution about glass, architecture, and our modern lifestyle.